Hi everyone, just welcome to a new video. So today we're going to cover a new topic. Well, it's not a new topic, but a new topic on the channel. And this has to do with Llama Um, it has been around for a while. Somehow I have not used it before, and the main reason was I could use without any trouble Llama CPP. That's been my favorite way of deploying LLMs on production. But lately Llama CPP has been updated and it cannot be compiled on my operating system, which is Ubuntu 18.04. And because of that, I found this something useful that I'm showing to you today. And this is possibly one of the best ways that I have now of trying new things, of trying new models that have not been included on Llama or any other inference engines. So because of that, I have some tests here to show you guys how it works, what you can do with it, and all that kind of stuff. So just to get started, this is the logo. This is basically Llama is a way of packaging on a file the LLM, the inference code, and any other thing that you could need in order to run LLM, open source LLM. And the main reason it's called LlamaFile is because it started with Llama. It has adopted new kinds of models, and it is just one file that you just double click or just open on the terminal and it works. So this is the repo, and well, this is the Llama CPP repo. It's based on Llama CPP, and yeah, basically if I try to compile the latest version of Llama CPP, it won't work on Ubuntu 18.04. I know I need to update the operating system, but that's not something I have time for. Because of that, well, you can see it supports Quen models as well, Granite, Mistral, a lot of them. It also does embeddings if you prefer. This is pretty useful. So the main reason I'm testing this is because I've been interested lately on 13 kind of models that has been around for a while as well. You can find them on Bitnet. Yep, here. Well, you can also find them on Hugging Face if you search for Bitnet. This is basically LLMs that are quantized to 1.58 bits on average for the whole model. They basically quantize 13 parts of the LLM, more, others not that much. And the average of the amount of bits that they compile to with respect to all the model is 1.58 bits. So this is something I'm testing. This is something that I just go through many topics as time goes on, and these days I'm just trying new things with this, just experimenting what it can do, because it is something that we really need. If you listen to podcasts on ELM ecosystem and all that kind of stuff, artificial intelligence, Gen AI, whatever, you'll find a certain trend that everyone is complaining about, which is basically that it takes a lot of resources to run LLMs in production for a lot of users. So yeah, that's something to test. That's something I'm testing with, and I don't like running things on Hugging Face Python. That's kind of something that has been since the beginning. I really don't like doing that for inference, so I just prefer trying different mechanisms. And there's another paper on top of that that tries to run DLMs as if they were ternary kind of data sets or kind of models, ternary models. So instead of having a 13 value, all the values get quantized to three possible values, three possible outcomes. That's the ternary part of it, and that's something that you can run on hardware very efficiently without the need of GPUs, or you just can consider an ASIC or an FPGA to run that in an optimal manner. So that's something these guys do, the 3LM paper does. and the Llama people, the Mozilla, this is from Mozilla. The Mozilla guys have done this 3LM as a Llama file, and they provide different sizes, as you can see. So if you want to install Llama you don't need to do much, but you need to consider the gotchas and troubleshooting. And for my example, for my case, I'm using Linux. Well, Ubuntu is Linux. You need to do these steps. I just copy paste all that stuff. This is basically so that it can understand the format of the Llama file. On Windows, you would need to do other things. On Mac OS, you would need to do other things if they are required. But without further ado, let's see how Llamafile works. So I have here, the only thing you need to do is just basically make any of the files that you want to run that you have downloaded before as an executable. So you go for chmod +x or a +x 3lm 1.1 whatever, boom, and then you just need to run this thing. So boom. Oh, this is weird. Yeah, so possibly we need to run these gotchas every single time. I may add them to the bus RC file. Didn't know that. I've been testing with this lately, but I haven't done anything with it today. So yeah, my bad. Yeah, possibly we don't need to do the executable, the downloading on the executable, but we need to do this thing. Boom, there you go. So as soon as you run the thing, it will launch a server, basically Llama CPP server, and all the logging that happens in here will be Llama CPP. So it just gets the model weight, you just get the inference code from Llama CPP, and then puts everything together. You run the executable, and as you run the executable, you just can use it and say, what is 2 + 2? All right. So before you get any mad on this answer that the model has given, this is something common and normal because these models are very quantized. They are small models as well, so 390 million parameters is very small. They also are very quantized, so things get worse very fast. So if you want to try, for example, this one should be better, I guess. Word is 2 + 2. Oops. Well, sorry for that. 2 + 2 = 4. Yeah, then it just goes off the rails. So this is an experiment. This is a fun experiment because also I don't believe these 3LM models or these BitNet models are trained or fine-tuned to become or to behave as an instruct model. So it's very likely that whenever we try to chat with it or whenever we try to make something like instruct base, it's not gonna work. So the best way to go, we can just test the bigger ones like 1.1b. So it's possibly just a compression of the internet, a compression of the common crawl or something like that. There's a huge need to fine tune on top of it, right? So the video is not about how good or bad the answers of these Llamafile or this 3LM is. This is just an experiment. I'm just trying so that I can see if I can run LLMs on very compressed and restricted hardware. But you can also search for Llama files on Hugging Face. There's plenty of them, as far as I can tell. Possibly the model that you're looking for is not as a Llama-file, but you can just ask the community, and there's plenty of them. The most famous models are here for sure. And this is very commoditized. You don't need to compile or recompile Llama CPP whenever a new version, new model is supported. You just can get the file that you desire, the Llama file that you desire from here, run it, run the inference, or just do whatever you need with it, and you're free to go. So I hope you like this video. I hope you understand or like what Llama-file could be useful for. Share any thoughts in the comment section down below. Share a like, subscribe, click the bell button, and I will see you on the next video. Bye bye.